Welcome! This video is brought to you by Forge College. In our last lesson, we explored the Solana official documentation, but now we're returning to our Ethereum fundamentals track. We are diving specifically into the anatomy of Ethereum accounts. An Ethereum account is a persistent row of data in a global spreadsheet. Instead of just tracking a single number for your money, every entry in this spreadsheet holds a specific set of fields that define what the account can do. It helps to visualize this row as a smart bank vault attached to a secret combination locker, all operated by a programmable robot butler. Getting comfortable with this vault structure is the first step toward navigating the rest of our Introduction to Ethereum Architecture course. First, let's look at the Externally Owned Account, or EOA. This is the standard vault operated by a human user, which only needs a simple front desk setup to work. This setup includes the balance, the vault's liquid cash, measured in Wei. Next is the nonce. It acts like a sequential ticket dispenser that clicks up every transaction. It keeps things orderly. The network rejects check 5 if check 4 hasn't arrived, preventing hackers from replaying old transactions. For human users, tracking the balance and the sequence of outgoing actions provides all the security the network needs. Then we have contract accounts. These are vaults controlled by code instead of people, so they require a specialized back room to hold extra information. This brings us to the code hash. Think of this as the robot butler's instruction manual, which tells the account exactly how to react when it receives a message. This manual is finalized when the contract is created. Once programmed, those instructions are set in stone. Finally, there is the storage root. This is a private locker where the contract stores its long-term data, like high scores or custom token balances. These 4 fields allow Ethereum to function as a shared global computer where logic and data live right alongside the currency. Let's see these fields interact. Suppose Alice uses a smart contract vending machine. She sends her request, her nonce clicks up, and the network deducts a small fee, gas money for processing power. If successful, the robot butler follows its manual and updates the storage root locker to reflect the new state. If the contract fails, like if the machine is sold out, the transaction reverts. The private locker remains exactly as it was, with no data changed. Just remember, even if the transaction fails and the locker stays shut, Alice's gas money is still gone. The robot butler expects to be paid for his time, even if he couldn't find your snacks. From simple transfers to complex apps, every action on Ethereum comes down to updating these 4 specific fields in a predictable, secure order. Mastering this field-based architecture makes the upcoming lessons in our Ethereum account model versus UTXO module much easier to follow. By looking inside the vault, you can now predict how the entire Ethereum network will react when the gears of a transaction start turning. This video was made by Forge College. Visit forge.college to dive deeper into the world of Web3 and continue your education.